Alright, so this is Business Calculus section 5.1 part 2, and in this video I'm going to try to get through all of the integration rules, and then the next video we'll do some applications. So the first one we're going to look at, still using that power rule that we learned in the first video, but integrating with other variables. Okay, it doesn't matter what letter it is, as long as your variable inside your integration matches the variable with the d. Okay, so we have the integral of d cubed dt. It's the same rule that we had. We've got 1 over 3 plus 1 times t to the 3 plus 1 and then plus c. That rule doesn't change for whatever variable it is. So we end up with 1 over 4 t to the 4th and plus c. And again, if you can see it without that middle step, without writing out that middle step, that's perfectly fine. Go for it. It's not a big deal. All right. On the next one, I have the integral of u to the negative 4th du. So I have 1 over negative 4 plus 1 times u to the negative 4 plus 1 and then plus c. I would definitely write out this middle step, especially with the negatives when you're first starting, just so you don't lose any signs, okay? That's where my biggest mistake comes, is I get going too fast and I lose a sign somewhere. But I end up with negative 1/3 u to the negative 3 plus c. All right, this is just a good form thing. Make sure that your negative floats out to the front or it's in the numerator of your fraction. We never leave a negative in the denominator. So make sure you're doing that as you're going through. All right, let's learn some more rules. So the second rule of integration says that a constant may be moved across the integral sign. So if you have the integral of k times f of x dx, that's the same as k times the integral f of x dx. Okay, so we can move that integral out front and not have to mess with it as we're dealing with our integration. Let's do some examples. All right, so example 5, I have the integral of 6x squared dx. So what this means is, and you've got two ways you can work. I'm going to show you both ways. I can move the 6 out front and then find the integral of x squared dx. Okay, so we know that that's going to be 6 times 1 over 3, because 2 plus 1 is 3, times x cubed, and then plus c. So you can write it out in two steps like this. 6 times 1/3 is 2, so I have 2x cubed plus c. All right, you have to have the plus c or it is wrong, so make sure you keep that. That's one way that you can write it out. You can move that constant out front and then take the integral of the inside separately. I don't do this all the time. To me, it's an extra step. It looks like more work, even though it really isn't. Here's how I normally write them out. I'm going to show you on part B. I've got the integral of 4x cubed dx. When I write this out, I automatically put a 4 in the top of the fraction. 3 plus 1 is 4, so I know I have a 4 going in the denominator. And then x to the 4th plus c. And then I just simplify my fraction. This is how it makes the most sense in my head. It truly doesn't matter. Pick the way that looks easiest to you or makes the most sense to you. But I would prefer the second one, because we know 4 divided by 4 is 1, and I have x to the 4th plus c. Okay? Now, how does that work if we're dealing with just a constant? Okay? If you pull that constant out front, so 7, if that 7 comes out to the front and we just have the dx, there's an understood 1 in here still. So remember from the end of the last video that the integral of 1 dx is x. So the integral of 7 dx would be 7x and plus c. Okay, so we don't have to take this step to pull everything out in front, knowing that a constant is just the integral, or the integral of a constant is just the variable times the constant. So on the integral 3 du, that would be 3u plus c. And you're done. And this leads us to a rule. So a very general rule here. For any constant k, the integral of k dx is equal to kx plus c. So the integral of a constant. All right, well, what if there's more than one function? So the constant multiple and sum rules for differentiation lead immediately to analogous rules for simplifying integrals. The first rule says that the sum of two functions may be integrated one at a time, meaning if I had the integral of x cubed plus 4x squared, something like this, dx, so I have two functions essentially in there, so the first one and the second one. I don't have to get overwhelmed that there's two things inside that integral. We just break it apart. So I really have the integral of x cubed dx plus the integral of 4x squared dx, which we know how to tackle. We can tackle each of those individually. That's the sum integration rule. Okay? If you have two or more things added inside an integral, break it apart, take the integrations separately. So let's practice that. On example 7-8, I've got the integral of x squared plus x cubed dx. Again, I'm not going to take this as a whole. I'm going to think of it as two separate integrals. So the integral of x squared is 1 over 2 plus 1, which is 3, and then x to the third power. Plus, okay, we don't do our plus c yet. Just do plus the integral of x cubed dx. Well, 3 plus 1 is 4. So I have 1 over 4 x to the fourth. And then tack your plus c on to the very end. Okay? At this step, you would simplify any fractions that you can. Here we can't. So there's the answer. So it doesn't matter how many things are added or subtracted inside your inside your integral, take it one step at a time. All right, so I want you to pause the video, work out B, and then come back and check your answer. Okay, so again, we're taking it one step at a time. I would have 6 over 3 x cubed minus 3 over negative 1 x to the negative 1 plus 5x plus c. Okay, simplifying everything should leave you with an answer of 2x cubed plus 3x to the negative 1 plus 5x plus c. And then you're done. So it doesn't matter how many things are added or subtracted inside your integral. Take it one step at a time. I didn't rewrite any of these, but if you wanted to take the time, just like it showed up here in that last side, if you want to take the time to rewrite each individual one, go for it. You can. It's not a big deal. I just chose not to. All right, so just like with the original problems and we did in video 1, if you don't have that an x to a power, you want to rewrite your equation so that you have x to a power. So on this next example, we're going to take the time to rewrite this. And I would rewrite the first one, that 3 square root of x over 2. We're going to group the 3 and the 2 together so that we have 3 halves. And then x to the 1/2 power. And then minus 2. And we'd have x to the negative 1/2 power. Remember, if you're moving anything up from a denominator to the top, we'll add the negative up there in the exponent. And then don't forget your dx. Since there's more than one thing inside the integral, you do have to have the parentheses around that function. Okay? All right, again, I want you to pause the video and see if you can simplify A, and I want you to also try to work B, and then we'll come back and check them. Okay, so for part A, we had the integral of 3/2 x to the 1/2 minus 2x to the negative 1/2 dx. So when you take the integral there, you'd have 3/2 times 2/3, because you recall 1/2 plus 1 is 3/2. And if I do 1 over 3/2, that reciprocal becomes 2/3. So you could either write it as the fraction 1 over 3/2 and then simplify, or just go ahead and simplify before you write it down and do 2/3. So we have 3/2 times 2/3, x to the 3/2, minus 2 over 1/2, or I could have done 2 times 2, because the reciprocal of 1/2 is 2, times x to the 1/2 plus c. And we end up with x to the 3/2 minus 4x to the 1/2 plus c. It's okay to leave it with fractional exponents. That's perfectly fine. But a good rule of thumb is that if your original problem has the radical notation, switch it back over to your radical notation in your answer. But it truly doesn't matter. They do mean the exact same thing. All right, on part B, if you take the integral of the cubed root of x minus 4 over w cubed dw and rewrite that, we would have the integral of the quantity w to the 1/3 minus 4w to the negative 3 dw. And again, we can integrate that. If I'm integrating w to the 1/3, that would be 1 over 4/3, because 1/3 plus 1 equals 4/3. So 1 over 4/3, w to the 4/3, minus 4 over negative 2, w to the negative 2, plus c. If we simplify, we end up with 3/4 w to the 4/3, plus 2 w to the negative 2, plus c. And again, just because going back to the same notation that we started with, I changed everything over to radicals and put the variable in the denominator for the second term. Again, it doesn't matter. They both mean exactly the same thing, but you would probably see the answers both ways depending on what you're looking at. All right, let's keep going. Stop it. All right, so there's some integrals that you want to be able to integrate, quote unquote, at sight. And it's just ones that hopefully as you're going through these and as you're practicing these, you're going to see them more as a pattern and see that pattern quicker. So the integral of 4x cubed dx is 4 over 4x to the 4th dx. And that 4 over 4 simplifies to 1. So I have x to the 4th. I don't need my dx here, sorry. 4 over 4 x to the 4th plus c, which simplifies to x to the 4th plus c. Right, and where we're seeing this and why we're saying this can be, they're so simple they can be integrated at sight. You notice the connection, or you can notice the connection between the 4 and the 3. If your coefficient is 1 higher than your exponent, it's going to integrate to whatever x to the coefficient. Okay, same thing works here on the integral of 7x to the 6th. I would have 7 over 7 x to the 7th plus c. So we could just integrate the integral of 7x to the 6th dx is just x to the 7th plus c. So some of these are going to be a little faster, and you want to be able to integrate those at sight pretty quick just to make calculating quicker. All right, we'll continue in another video.